boundary layer separation and methods of controlling boundary layer separation. This is our new topic. Good morning to everybody. Convergent flow, that is a negative pressure gradient. Why it says the negative pressure gradient? Because the section is the convergent. So diameter at entry is more than at exit. So pressure accordingly here goes on decreasing, velocity increasing. So P1 is greater than P2, U1 is less than 2. Divergent flow positive pressure gradient. Here the reverse is arrangement. Here P1 is less than P2, U1 is greater than U2. So your velocity at the entry is more than at the exit. Pressure at the entry is less as compared with the pressure at the exit. Convergent flow, divergent flow. Initially pressure decreases and velocity increases in the convergent flow. In divergent flow, pressure increases and velocity decreases. Second important point is the here we exist negative pressure gradient because P1 is less than P2. In the second case, positive pressure gradient because P2 is greater than P1. Therefore, dab of P by dab x is less than 0, favorable in case of convergent flow. In case of divergent flow, dab of P by dab x greater than 0, adverse pressure gradient. In convergent flow, fluid particles are accelerated because the velocity is increases. In divergent flow, fluid particles are decelerated, that is the retarded, where in this case it is a decreases. Boundary layer separation as shown in the figure. So in case of the convergent flow, flow accelerate initially. In case of constant diameter, that is a you see that is called as a throat section where the constant flow is there. Again it is gradually increases, that is a diverges. So in the convergent case, delta P by delta x less than 0 is the favorable pressure gradient. In second region, boundary layer region, delta P by delta x 0. No gradient because the pipe is straight. In case of the third case, flow decreases, delta P by delta x greater than 0, adverse pressure gradient. So from the figure you see the boundary layer region by red mark and separation point you can see from the dotted red line. So in the at the exit flow reversible take place. So in the favorable case Uy is equal to 0 plus delta y. U equal to y equal to 0 plus delta u by delta y to y equal to 0 into delta y. This implies that 0 equal to 0 delta u by delta y at y equal to 0 into delta y. This implies that du by dy at y equal to 0 is 0. So from the figure you will get the clear idea about the boundary layer separation. It shows initially pressure is max, then it is minimum and it becomes actual. The flow takes place here. So at the point A, B, C, S, D, you will get the different velocity gradients. Delta, thickness. So you can see the edge of the boundary layer. Separation of the streamline takes place and the flow becomes the reverse flow at the exit. So initially at a delta u by delta y at y equal to 0 is greater than 0. Point of separation is where the fluid separates. Delta u by delta y at y equal to 0 is equal to 0. And at the point D where the flow becomes reverse. Delta u by delta y at y equal to 0 is less than 0. So we will get the clear cut height. Location of separation point. The separation point as showing in the figure can be located from the condition delta u by delta y at y equal to 0 is equal to 0. First, if delta u by delta y at y equal to 0 is negative, the flow is separated. In the second case, if delta u by delta y at y equal to 0, the flow is on the verge of separation. And third condition, if delta u by delta y at y equal to 0 is positive, the flow will not separate to the surface. You see the examples of boundary layer. In the first case, you can see the flow gradually diverges. In the second case, you can see there is a flow divided into two regions, and you can see how the boundary layer separated. In the third case, when fluid flows from section 1 to 2 and 3, you can see separation of the boundary layer. And in the fourth case, if you can see the flow passes through a circular path, how it separated, you will get the idea. Effect of separation. Large amount of energy is lost. Bodies are subjected to lateral vibration. Pressure drag is increased. Hence, additional resistance to the movement of the body is developed. Methods of avoiding separation. So, how you can avoid a separation? First, by streamlining the body. In the first case, you can see on streamlined body how the liquid passes from separated zone SS to large wake. That is the case of unstreamed line body. In case of streamlined body, you can see a aerofoil section in which the fluid passes and the viewer see a small wake SS as compared with the unstreamlined body SS. Point of separation is shifted as far as possible on downstream side. Our wake region becomes narrow. Pressure drag reduces. So that is the effect of aerofoil section. By providing artificial roughness, you can see initially when the liquid flows, a large wake develops. Artificial roughening. In the second case, in the figure, you can see how rough the section is made. So because of that, small size of the wake is there. It is provided in upper section which changes laminar boundary layer to the turbulent laminar boundary. So from the figure you will get the idea. The sphere is a smooth sphere. You will get the thick wake. Laminar boundary you can see with the red. Now the fluid is separated by separation zone. But in the second case, golf ball, instead of the smooth sphere, if you kept a golf ball, you see the transition region. Laminar boundary layer changes gradually to the turbulent layer. Separation takes place and you will get the thin wake at the exit of this. Third, suction. Now, a aerofoil section, there is a small gradual circular hole is provided where fluid passes. So because of that, wake decreases. Retarded fluid is sucked out through the suction slot. Next, by blowing, additional energy is supplied in the retarded fluid. If you give additional energy, you see how the retarded fluid moves and you will get the at the exit a small wake, making slot near leading edge. In the first case, you see the large wake is developed and the reversal of flow takes place. But whenever you provide a slot near to the leading edge, causes fluid layer to remain attached to the upper surface. So size of the wake decreases. Sixth, by using guide vanes. Now whenever a fluid flows through a rectangular pipe, separated zone at the corner you can see by dotted line at the upstream side and separated zone at the downstream side. But if you provide the guide vanes, flow moves gradually, becomes streamlined. So no separation of boundary layer take place. Numerical on the basis of this. Problem. Velocity distribution is given below. Find whether flow is attached or detached, separated. Small u upon capital U equal to 3 by 2 y by delta minus half y by delta bracket. Solution. U upon V is equal to 3 by 2 y upon delta minus half y by delta bracket cube is given. Therefore, U equal to 3 by 2 uy upon delta minus u by 2 into bracket y by delta bracket cube. Differentiating with respect to y, you will get du by dy equal to 3 by 2 u by delta minus 3u by 2 into y square upon delta cube. Therefore, this implies that du upon dy equal to 3 by 2 u upon delta minus 3u upon